Alrighty, and now we're getting to like one of these tricky questions here where I tell you something, right? At 3.2 seconds after launch, and I think I've chosen time after launch, vertical elevation, and then horizontal distance as the little things I tell you, right? Okay, so 3.2 seconds after launch, what are the position of the ball and the velocity of the ball in vector components? Write them both as proper component vectors. Proper means it looks like this. Something X direction, Y direction. Oh my gosh, look at this typo there, right? This needs an X hat to be proper, like that. It's going to look like this, okay? So let's see, write them both as proper component vectors. Okay, so remember that it's still the same problem, right? So the same components you used before, let's use that, right? So this we got with cos, 27.2. Cos of that is 7.0399, right? And the initial velocity here was 26.73273. Okay. And then the same things are true that are always true. This is 0. This is negative 9.81, right? The 3.2 seconds goes here, right? And then the only other things I'm going to tell you, by the way, I'm going to tell you like this horizontal distance, right? And I'll do some more of those in videos. Or I'll tell you this displacement here. And then you can solve it, right? You always have this. If you're launching at some angle, you always have these two. And so it shouldn't be too hard. Okay, so I can bring this guy down, right? Because this is 7.0399. Since it doesn't change, right? It's just constant velocity. Let's see our final velocity here. Oh, we got to figure that out, don't we? And we got to figure this out and this out. Okay. So I choose, let's find this horizontal. This is easy, right? Let's go S is UT. So it's 7.0399 times 3.2. That's easy. So for me, that's alpha A times 3.2 because I stored that value in alpha A. I get 22.527. Let's see, and there we go. It should be 22.5 meters, so we're good. Okay, and now we want to find our displacement here. And since there's acceleration, this is full featured, right? So I think what I'll do is I'll use this guy. But ultimately you'll use this, but maybe not. I don't know. There's probably, it just depends on what I tell you, right? Okay, so let's see. S is, our displacement is 26.273 times 3.2 plus 1/2 negative 9.81 times 3.2 squared. Okay, here we go. 26.273. Is that what it is? Yes, it is. Okay. Times 3.2 plus 0.5 times negative 9.8. Don't forget to make G negative. Times 3.2 squared. 33.8464. Okay. Okay, so now let's find the final velocity. Find the final velocity down here. I'm going to use, I guess I'll just use V equals U plus AT. Okay, so the final velocity is 26.273 plus negative 9.81 times 3.2. Okay, so here we go. 26.273 plus negative 9.81 times 3.2. Ooh, look, it's going down. I get negative 5.119 meters per second, right? Okay, now it says write them both as proper component vectors. If you notice, what we've got in our little horizontal vertical table, this is just X hat, this is just Y hat, right? Okay, so what we've got is this guy, right? Notice this is our component vector, right? But we just have to write it the right way. 3 sig figs 22.5 in the x direction. That's our horizontal position, right? And then what is that? 33.8 in the y direction, right? So there it is. There's our position vector, right? So this thing's flying through the air. It's going like that, right? Oops, that's not good. It actually goes really high, doesn't it? Like that, right? Okay, and at 3.2 seconds, it's already on the way down. It's like here, right? It's over that far. It's up pretty high, right? It's over 22.5, and it's way up in the air. Okay, and then our velocity, our final velocity are these guys, right? So, right, I can pull these guys out and write them as, let's see, 7.04, right? And that's meters per second in the x direction. Now, no, it doesn't matter where we look at this whole projectile motion, right? The x component is just solidly going to be 7.04 meters per second in the x direction, right? And then it's negative 5.12 meters per second in the y direction. So there's our answer to this one, right? And this is one of the forms I want you to write the answer in. I think one of the other things I ask for is give me this as components, and then, or give it as an angle magnitude. Of course, you got to have the components to do that, don't you? All right, so that is part 1.